We will be studying the conservation of momentum in collisions. In an elastic collision, the two objects do not stick together. We can understand the motion in an elastic collision starting with the law of conservation of momentum. The momentum before the collision of the system is equal to the momentum in the system after the collision. We can break that system into two objects, cart momentum 1 and momentum 2, the original momentum and the final momentum, remembering that momentum is a vector. Momentum, remember, is mass times velocity. So mass 1 times velocity 1 original, mass 2, velocity 2 original, and so forth. And this comes up with the law of conservation of momentum as we see it. Sometimes in elastic collisions, there are losses of energy through sound, heat, or deformation if the two objects in this elastic collision actually make contact. Good. Thank you. In the previous clip, you could hear the sound of the collision. In the next clip, which is perfectly elastic, there is no contact. You will not hear any sound because the collision takes place via the force of magnetism. Let us analyze the collision that we just saw. We'll start with the law of conservation of momentum. We can define each cart as having a mass of 500 grams. Cart 2 is initially stationary, whereas cart 1 has an initial speed of 5 meters per second. We want to find the final velocity of cart 2. As we saw in the video, the final velocity of cart 1 stopped. First, we can cancel out one term because the original velocity of cart 2 is 0. We always want to isolate the unknown. Always do the algebra with these types of equations. You'll find it's much easier if you solve the algebra first before you plug the numbers in. So we've isolated V2 final. Now we plug in the numbers, 500 grams for the mass, 5 meters per second, and lo and behold, we get 5 meters per second for our final velocity. We will now examine what happens when a larger object hits a slightly smaller object. On a pool table there's contact, so we can actually hear what happens.
Whoa.
Now we are going to put an extra 1,000 grams on cart 1, and cart 2 will remain empty. And we will push cart 1 into cart 2. Now let us calculate the speed of cart 2 after the collision. Cart 1 has 1,500 grams. Cart 2 has 500 grams. The original speed of cart 1 will set at 6 meters per second, and cart 2 is stationary originally. Let us assume that the final speed of cart 1 is 3 meters per second. What is the final speed of cart 2? Again, we start with the law of conservation of momentum. We identify which variable is the unknown that we want to isolate algebraically, find out which terms might zero and go away, and then we solve the algebra to isolate V2 final. After we have isolated that variable, we can plug in our numbers and plug in the 1,500 and the 500 grams. It's important not to drop your units out. And notice that the grams will cancel from both the top and the bottom, so it doesn't matter that we have not converted to kilograms. Now let's examine what happens when a lighter cart hits a heavier cart. Watch carefully. The 1,000-gram bricks are placed on cart 2. And look how cart 1 rebounded. Now let's do the physics. But let's try and calculate the cart of speed or of cart 1 after the collision. In this case, cart 1 has a mass of 500 grams and cart 2 has a mass of 1,500 grams. Speed 1 original, again, is 6 meters per second. Speed 2 original is 0. We're going to find V1 final. V2 final, it kept going, so let's say that's 3 meters per second. Again, we start with our law of conservation of momentum. Which variable do we want to isolate? Zero out the terms that we can get rid of to make the algebra simpler. Isolate the unknown term, and then we can plug in the numbers. The interesting thing to note here is, remember, momentum is a vector. The negative signs do matter. Remember, cart 1 actually rebounded like a small car hitting a brick wall. So our final velocity that we should expect should be negative. And indeed, when we plug the numbers in, that is exactly what we will find. And we will find that the final velocity is negative 3 meters per second. An inelastic collision is when objects stick together. These carts will stick together using Velcro. Momentum will still be conserved, and we can analyze this. The theoretical equation for an inelastic collision is just a slight modification of the equation for the elastic collision. Really, the only difference is that the final velocity of both carts after the collision are the same. And so since they are the same, we can simplify this equation.